It's 4 o'clock out here in Europe, different maybe for some of you somewhere out there in other regions on the world. Welcome everybody. We're again picking up our webinars and this is number 85 and today I have as my guest Patrick Schiefer. I know I put 2 F's, sorry for that. I should have changed that, but as the recording was already running, we somehow pushed the wrong button. I wasn't able to fix that, so excuse me for that, but I'll, well, everywhere else I think I wrote it right. So welcome everybody. Patrick, welcome, and I'm very pleased that you picked up my invitation. I saw you presenting this topic more or less when in Lyon, Directions EMEA last fall, and I thought that was very meaningful and I thought also useful to share with others in the community. So as you can see, and as you know, everybody that join in, Patrick is going to talk about object-oriented approaches in and design patterns in our daily work as AL developers. Before I'm going to hand over to Patrick, I'm going to through the let's say housekeeping things for those not yet having been attending one of our previous webinars. As you might have noticed, your microphone is muted. However, we're very much inviting you to be involved by posing questions using the question window on the GoToWebinar console. And I, Luc van Vugt, will be the moderator picking them up, and we agreed if it's in the context directly of what Patrick is discussing, I will step in with the question, and otherwise we'll do it at the end. So be more than welcome to do that. And as you all know, this is recorded. I mentioned already the recording was already running. I need to get rid of that part before I'm going to put it on YouTube. And yes, this is our channel. This is, by the way, a print screen of the website page where I integrated the YouTube recording. So you either go to the channel on YouTube or you could play it from our website. Be welcome to share, to give feedback. On the website, in the comments, you will always find a table of contents where you can directly jump to a specific part that has been identified in the table of contents. And if you want to be in the know of what's ahead, this is the URL to subscribe to our newsletter. Slowly picking up things for the next sessions. Well, next sessions, as you can see here, on April 29, there was already planned a session by Dimitri Katzen, on May 13 by Niall McGovern, and last week it was Days of Knowledge Nordic in Odense in Denmark, and I talked to Milan Milicevic, and he was willing to come up and be a speaker too. It's the topic that was on the Days of Knowledge, but there's a discussion still going on, so the title is not yet set. And yes, 2 other dates, June 10 and July 8. Made a typo there, it's not July 9, July 8. There will be some other sessions too, and as you can see, I'm already setting up things for the next season. And there's a group going to join me in on what I'm doing to help me to get things in place. So let's say some others are also hunting for topics and speakers, but nevertheless, if you feel like to be one, let us know, and be more than welcome to do your part on this. So before I'm going to hand over to you, Patrick, I want to thank Fornaf being our sponsor, enabling us to do this. So I'm going to make you presenter, and then you should be able to share your screen.
So hello everybody from my side. As Luc already said, I'm talking a little bit about object-oriented design approaches in Business Central. Before we can start, here are some resources for you which I've used for this presentation. First of all, my GitHub repository where all my solutions which I will show you during this webinar are already there. As Luc said, it was a presentation for directions, that's where it says directions to 2023. And yeah, we'll step into some of these solutions. Object-oriented development is a design approach which allows you to write very flexible code and to write less code and do more with less code. And you think more about objects and not so much about code. So I will show you what I mean with it in a few moments. But before we start, we have 4 facts about Microsoft AL. First of all is Microsoft AL is not object-oriented. But it uses .NET as an underlying technology, and .NET is fully object-oriented. And every AL code is translated into C# in the background. So it gets object-oriented at least at this point. And C# has value and reference types like every object-oriented language. So I think they moved something, but it's not relevant. I will just describe. We have value types, which are all basic types like integer, text, boolean, character, or something like that. And we have object types. So every complex type is an object type, which is stored as a reference in the memory. So code units, for example, tables, interfaces, and everything which can have procedures is an object type. The 2 types have different behavior. So many of you might know if you assign a value to an integer, the variable in the memory. So on the right side, we have what's happening in the memory of your server. When you assign a value to an integer and you just copy this to another integer, both variables have the same value. That's quite clear. And if I assign a new value to the second variable, first variable doesn't have any changes. So the first variable still stays at the same value. When we think about reference types, they act a little bit different. So in this case, I just created a code unit which is representing an integer. So it's more or less an integer. We have a set value and a get value. And we do the same as we've done before for this code unit. So we set the value of a to 5, and we assign the second variable to a, and then we change the value of the second variable. So when we think about the last example, a.getValue will give us 5, but not for reference types, because when we look at a reference type, we have every variable is a reference, so we have an instance behind this variable. And when we assign the instance of A to the variable of B, both variables now referencing to the same instance. And when we assign the value of 10 to this instance, both variables now have the value 10. So that's the main difference. I know for some of you this might be clear, but I always see people which are not know this fact, and it's very important if you work with complex patterns. What can we use from an AL perspective to work object-oriented? We have interfaces for, I guess, 2 years now, and interfaces can be used to make AL a little bit object-oriented. But what is an interface? It just defines which procedures a code unit must have. It encapsulates a code unit and hides the original object behind the interface. So, for example, if we have a code unit which is called export header, we have a function called export header. The code unit may have additional functions like, as you can see on the right side, the code unit may have a function set sales header, set only released, or something like that, and we will have some variables. But when we now use an interface, for example, we have an interface data exporter, which only has the function export. The interface is a capsule around the code unit, and using the interface, we now only can use the export function. But as you can see on this picture on the right side, the original objects with all its properties and all its functions and so on is still there. We just cannot access it via our current object. So for that, I have a small demo. I have an interface. I start with my integer code unit. I have an integer code unit, as I showed you before, with a set value and a get value. And I have functions for subtract and a function for add. And I also have two interfaces implemented here. So if you didn't know, a code unit can also implement more than one interface. And these interfaces both share the function get value, and one is adding the add function and one is adding the subtract function. So inside of my demo page, I have a code unit myInt, which is initialized with the page, and I have two interfaces variables, and I assign my code unit myInt to both of the variables. So when we remember the reference stuff, myInt, subtractor, and adder are all pointing to the same object now, which means when I change one of them, every three of them change. Let's start up my container. Just to get my password. In the meanwhile, I show you which fields I have on my page. So I have three fields. I have one field for myInt.getValue, one subtractor.getValue, and one adder.getValue. So I have three variables, and every of these three variables is here, and I can change the values. And if I change one of them, every three of them are changed because they are referencing the same object. What I'm not so often using in this webinar is the default way Microsoft is using the interfaces. Microsoft is using the interfaces via an enum. I guess most of you know this already, that you can have an enum, and this enum can implement interface, and you can assign an implementation to every interface, to every enum value. But for my webinar, I'm not using this so much because I want to assign the implementations on my own. So, and was a little bit about interfaces. So now we will go into implementations. We will today talk a little bit about design patterns. So there are different types of design patterns. First of all, we have creational patterns. They are not so commonly used in AL. There are some examples where it might be useful. Examples are for here the builder, the factory, lazy initialization, and singleton. Singleton is used in AL, but it's used in the background when you set a single instance property at the code unit. It automatically is a singleton in the background, and you don't have to care about this pattern. And also the lazy initialization, which we will have a look later, is used in the base app sometimes to save some resources. Then we have structural patterns like the Facade. Facade is used quite heavily in the system app from Microsoft. So I guess every module in the system app has a facade. We will have a look. Then we have adapters and we have proxies, for example, and there are many more. So structural patterns are here to change the way our code is structured. And we have behavioral patterns, which are here to change the behavior of our code. So if we want to change the way our code is working, we can use these patterns. And we will have a look at some of them also. So we start with a very simple one. The template method pattern is used to solve similar problems in a similar way. So when you have code units which are looking quite the same, then you can use a template method to extract the generic functionality out of this code unit and only implement the specificas inside of code unit. For example, some kind of this pattern is used for the new price module. It's not so clear to find, but if you know the pattern, you may find it inside of the price module. I have an example here, of course. We start with 2 code units. I will do a little bit of refactoring now. We have here 2 code units. We have 2 code units. One is a sales export and one is a purchase export. And the both code units look kind of the same. So we have a set function, which is of course specific because in the one case we set a sales line, in the other case we set a purchase line. But then we have an export function, which is doing exactly the same. We have a get line function, we have a next line function, and so on. So except of the set sales line, the structure of this code unit is the same. So maybe we can refactor this a little bit, and I will now show you how we can do it. We will now do create a new interface, which is called iExport. iExporter. I call it iExporter. So, and we now use just these procedures from here. Oh. I call it export here because I don't want a specific name inside of my interface. And just do a little bit code redesigning. Did I forget something? No, I didn't forget something. So now I can use this interface and implement inside of my code unit. I just have to rename this function to export. And so the first step of our they have a return value. So I forgot this return value. Okay, so I now have an export code unit, and I have a second one, which is also an export code unit. And I will also rename this function here. So now we have 2 code units at least implementing the same interface. And we still have here a function which looks exactly the same. And we now change this function to be a template function because we want to use it for future exports also. So now we have create a new code unit. I call it export template. And instead of having this export function in here, give the function the procedure to the export template. But now we need to know what we want to export, and we want to export the data inside of the interface. Therefore, we have the interface exporter here, and now we can just change this functionality here in here, and yeah. But now we have the functionality in here, and we don't need it inside of our export code units anymore. So from here, okay. So now we have a template method which is able to export every data which is is using every code unit which is implementing this exporter interface, and we can use it for every future export. So if a colleague is now starting with this project and wants to create a new export, he is just going to create a new code unit, maybe call it service exporter. We create a new code unit, call it service exporter, and implement the code unit, the interface. And when we click to implement interface, the new colleague which is doing this export already knows what she has to implement, and he don't have to think about what he has to do to export data. And it also ensures that every export in your code looks the same way and you don't have different types. Okay. Let's head forward. If there are any questions, feel free to ask. Luc will forward it to me.
No questions so far.
Okay. Then I already talked about the Facade, which is Microsoft using in the base app. The Facade is just a pattern to hide complexity in the background, and it is easy to adapt in existing code without doing any breaking change. For example, Microsoft has done it in the language module. The old language code unit is still here, and we have every function in here, but we do not have the actual implementation in here because the old language code unit which they have refactored is just a Facade now, and the actual implementation is in a second code unit. That gives Microsoft the advantage that they can do every change inside of this code unit. The access is also set to internal, so you cannot directly use this code unit. You can only use the Facade. And if Microsoft wants to change something inside of this code unit, as long as the Facade stays the same, it will not have any effect and will not break any other apps. So if you're doing product development or something like that, Facade is a good pattern to keep your app very stable and keep your apps away from breaking changes. Also very similar is the proxy pattern. A proxy is an intermediate layer between a caller and an object, and it can add additional checks. For example, you might know an internet proxy. If you want to access a site and you have a proxy in between, the proxy is checking if you are allowed to call this site or if there are any additional security things to check. So similar to that, you can implement a proxy inside of Business Central in AL for every code unit. It's a very simple pattern. So in my case, I have a calculate procedure, which can add just two integers, a very simple code unit. I also set the access to internal because I want to only allow the access via a proxy. Therefore, I implement an interface iCalculate. The interface iCalculate consists of one procedure, which is also the add. And now we came to the proxy. I have two proxies. I have two implementations. The first one is no proxy. So yeah, if you are not using any proxy, which just use the calculate code unit, which I showed you. But then I have a second code unit, which is a proxy. And the proxy code unit, it's called only positive proxy, which more or less clear what it does. It just checks if both values you are passing are greater than 0. And then the proxy, after the proxy has done all his checks, the proxy will call the original object. So when we go to Business Central, of course, it's not very complicated. Somehow my loop doesn't work. Proxy. So of course, when I do something like that here and I calculate, it will work. And also if I do something like that, it will also work. But as soon as I switch over to use the proxy, I get an error. So for example, you could use this for different. For example, if you want to do web calls and you have different systems you want to connect to, you can have a proxy for each system, which is checking the headers and so on if they are in the correct format before you send the data. Let's head over to the command pattern, which is one of our first behavioral design pattern. Behavioral design patterns, as I said, manage how our code will behave. So in fact, the command pattern is very similar to events, but it gives you more control than a normal event subscriber and the publisher. And it contains at least 3 elements. We have iCommand interface, and we have implementation of the command, and we have one code unit which is calling the command. So for example, you might have seen code like this. It's not actual code, but you might have seen something. You have for example, a post sales document logic, and you have a function which is called post and print, and you have a function which is called post and export. And you might have additional functions. And every time you add a new functionality, you have to change this code unit because you have to add a new function to this code unit. Or if you don't want to change this code unit, you have to create a new code unit. Instead of that, we can use the command pattern, which looks very easy. So we have, as I said, an interface which is called iCommand, which has one procedure execute. Depending on your use case, you can have iCommand int, for example, which is giving here an parameter, but in my case, I don't use any parameters. And when we now go to the post document example, we now have this post function as we had before, but in my case, I am now passing an additional command which is executed inside of this code unit. So from here, I don't know if which command is executed. So that's what I said is very similar to events. But I know something will be executed here and I can react to it. But when we go to the calling code, where is my example here? For example, I have the printing and the posting, which the printing and the exporting, which I've showed you in the slides before. So I have now a print command, and when I post the document using the post document function, I'm now passing the print command. So from the calling perspective, where I call this functionality, I know exactly what is happening. There are no code which I don't know is executed. And I can easily control what is happening. So in the second example, I have an EDI command, and I use the same post functionality, but the command which is executed is different. And when we have a look at the implementation of the command, it's very easy. It's just implements the iCommand, and of course I have here the implementation. I didn't actually implement the export, but it just gives a message. And so I have this queue, these two examples. I can export it to EDI, or I can post and print it, and both will do the posting, but only one of it will print it and one will export it. So when I now want to add another functionality, like, for example, posting to a web service, I just need to create a new command code unit, and I don't have to change the posting routine, because here's everything prepared for it. I just have to add a new action here, which is doing the export to web service, for example. Very similar to the command pattern is the command queue. Command queue, let's start with the queue. The queue is a collection. Collection is just like, for example, the list which was introduced some versions ago in AEL. It's just a collection of data, and a queue is a collection where we have a first in, first out. And for the command queue pattern, we want to add commands to a queue and execute them in row, so we can control the flow of a process. The minimum requirements for a queue are two functions, so two procedures. We have a push and a pop, where the push is adding something to a queue and the pop is removing something from a queue. And we have one property we have two properties. We have the first entry and the last entry. Just to know how the queue looks, we need to have some references to the data inside of the queue. Because of many collections at AL at the moment not supporting variant as data type, I've created everything on my own. So I created a queue entry which holds an interface from iCommand, and the queue entry will be added to the queue, and then we can iterate to the queue. Let's have an example how this all works. I will show you the code later. So how does a queue look? When you add something to a queue, the reference from the queue will get to the first queue entry. When you then add a second, so this is first. When you add the first entry to a queue, both connections will go here, and you only have a first and not a last. So the last queue entry is also going to the first one. And when you then add a second queue entry, the connection from the last queue entry goes to the second entry, and the first queue entry gets a directly connection, which we have here, to the second queue entry. That's relevant because when we have a look at the next slide, when we add a third one, so we have here the first and the second one, the third one is getting the new last, and the second one is just hanging around in between the first and the second one, and the first and the third one, and you will not have any connection from the queue to the entries in the middle anymore. So what happens when I want to delete something from the queue? When we delete something from the queue, the first entry will be deleted because it's a first in, first out. We don't have this connection anymore, and the second entry is now getting the first entry, and so on. And when the second entry will again be removed, the same thing happens again. Using this, we can iterate through the whole queue and execute commands inside of a queue. So when we go back to the code, I just have my backup slides for the code. When we go to the command queue, we have, first of all, we have a command queue, which is managing the whole code. We have a function push for adding new comments. We have a function pop for removing comments. We have a helper function get size, which is just returning the count, the current. And we have a helper function process queue, which is executing everything in the queue. So let's start with the push. As I've showed you in the image, when you add a new entry, if you add the first entry will get first and last at the same time because there's only one entry. After that, when you add something new, the previous last is now getting the previous last and it's not the last anymore. So you connect the new entry to the last and set the last to the new entry. So you move the queue upwards, and you counting up the size. And if you pop something from the queue, you want to remove the first one in the queue. So you get the value of the first, and the first is set to the second. So you move forward once in the queue is removed by once. And when you process the queue, it's just a loop while size greater than 0. You pop something from the queue and then execute it. What can it be used for? I have an example here. So we have more or less the same code unit as before, but now instead of passing a comment here, I pass a whole comment queue here, and now I can have more than one command here, so I can execute 2 or 3. I can execute 2 or 3 or more commands, and I have not a limit which commands I want to execute. So for the sales order example, which I had to here, for example, create a queue and push both entries. I push both commands and then execute it. So when we go back to our example, it will now bring the message, and it will also do the printing. But that's just one use case. Was once asked if this comment queue thing can be used for something like macros. So you may know macros from different programs. And yes, it can be used. You can store actions inside of queues, inside of commands, and execute them again. To show you something similar to that, I've implemented a batch post inside here. So I have a function which is called add to batch post, and I want, for example, post the first one. I want to also post the second one. Add to batch post. And then I want to execute batch posting. I know there's something already inside of the standard. Okay, in my case I cannot post because there's nothing to post, but now the whole queue would be processed, and you can go for a coffee or something like that. You just start everything you want, and just to have a look at it, how it works, it uses the same comment queue I've already prepared. So comment queue is a very generic code unit, and I've just have a posting command here. The posting command is very easy. I have a function get header, and of course I have the execute function, and I store a sales header inside here. So every time I click on add to batch post, I use this posting command, get the header, so that the current header is stored inside of it, and then I push it to the post queue. Post queue is stored here as a global variable. And when I click to execute batch post, I just process this queue. So it's very easy to execute more than one command in a row. I have 2 patterns left which I want to show, maybe 3. One is the state. State is also a behavioral pattern. With states, you can change the behavior of an object based on its state. So what does it mean? You see states everywhere, and I have a very simple example. I have a login state. So I have an interface which has 3 functions. I have a login state, a login function, a logout function, and a get state description. And I have 2 states. I have a logged in state. When I am already logged in and I want to log in, I get an error because I'm already logged in. When I want to log out, I start to log out. And I can get the state, the current, and change it. And when I'm logging out, when I'm currently logged in, I have to change my current state to logged out. I will show you in a few seconds how it worked. And I have more or less the same code unit for logged out state. So when I'm logged out and I want to log out, I get an error. And when I want to log in, I'm logging in. And if the login was successful, I change my current state. So I have this login state code unit, which is more or less a facade, but it has not one implementation, it has more implementations. It has one implementation per state, and it stores the current state in a variable. And I have some helper functions in here. So when I call now login via this code unit, it executes the login functionality from the current state. So it depends on which state you have at the moment, which login function is executed. Same for logout and for the get state description. At the transition, which I showed you before, just changing the current state to whatever you want. So for example, default value, when you start a system, you are logged out. I can click on login. The description changed to login. When I click again on login, I get already logged in. Even if there is no if or case or something like that, where I check if I logged in, because the state pattern does this checking for me. When I click to log out, it says logging out. And again, if I click on log out now, I'm getting an error because I'm in the logged out state already. So this can be used in different use cases if you have something which is relying on different states. For example, you could also use it on documents when you have a state or a status on your documents, open, released, or something like that. Then you can use also this pattern for different functionalities to not need to check every time if the stage is the status is open or if the status is closed and so on. One last pattern which I want to show you. And we have here, it's the lazy implementation. And lazy implementation is used in the system app sometimes. I think we will also find in the base app. Lazy implementation means that you only initialize an instance of an object when you need it, and you can also use it for database reading. For example, you may have done it or you may have seen it for setup tables. There is a function get setup, and in this function there's an if setup initialized, then exit. If setup not initialized, then get the setup. This is a lazy implementation, lazy initialization, and we have an example here. I found in a current module. It's the REST client, and we have here a function which is called get initialization. Again, I check initialized, and every time when a function is executed, it checks if it's already initialized, and if it's not initialized, then it will get initialized. So you don't initialize this whole code unit when you don't need it. This spares resources on your server, and in case if you use it for database reads, you can spare a lot of resources on SQL Server too. because you don't need to read anything at the beginning of a code unit. So that more or less everything I wanted to show you today. Yeah, that's just a few patterns which you can use to improve your extensibility, you improve your flexibility in your code. There are many more. I just showed you a few of them. When we go back to the resources page at the beginning, I've mentioned already the Gang of Four design patterns. Most of the patterns I showed you today are from there. I think I'm not sure if something is not included inside of this book. So if you don't know this book, maybe think about buying a copy of it, or you also find many of the patterns from this book in other resources. Yeah, the book is written in C++ mostly, I guess, as far as I know, but you can use mostly everything in AL too. So if there are any questions left?
There are no questions. so you really pinpointed. Well, that's I'm glad again to see this. Happy that I asked you, but I do understand being one of those dinosaurs, and some are sitting here also in the audience. That it's quite a step away from. We always have been programming this. Procedural functional flow and had a hard time to abstract things, but I really love what you showed to us, and I hope the audience also did. So I'm very happy you did. So, but yeah, there's not questions. Peter Konijn says very interesting and clear. Thank you, Patrick. Arthur writes, impressive. It's a lot to take in. So no questions right now. Let's say in other words what I was saying, and the questions will come in when working on it. So as you might all know, I didn't mention, and actually you did not introduce you that much, Patrick, but Patrick is MVP since start of April, I think, or was it already? No, it was already before that, I think. Yeah. So
it was start of April.
Yeah, so you will see him around many places. I reckon you will also be at the BC Tech Days, Patrick.
Yeah, I will be to BC Tech Days.
Yeah,
I will talk a little bit of about the connectivity between on-prem and SaaS on BC Tech Days.
If anybody's going to be there, of course, and you have questions, you will find him. And of course, you find him on Twitter, wherever. Thank you very much, Patrick, for joining and giving your input on design patterns. What's remaining is thanks everybody for being here. James Reinhardt also says great information, gives me a lot to consider. So I think it was very good to do, and there's quite in our environment, in our world, for quite some people not being object oriented from long time, a lot to learn on this, but it feels really like, oh yeah, like Arthur said, we need to do things and then run into and find out, oh, it wasn't that simple. It looked very simple, but now we have a recording, so you can always go back and put your questions underneath if you want to. I'm monitoring them, and in this case, if you have questions and I'll need to ask Patrick, I'll point him to it, and you'll probably get an answer. So nothing left, I think, for today. Thank you very much, everybody, being here, and hope to see you in 2 weeks' time when we have Dimitri Katson with the next webinar. Thank you all very much.